let's start off with how big are HTML elements without any CSS? Has anyone seen a browser like this before? It's very old. It's called a line mode browser. So back in the day when the web was invented by Tim Berners-Lee, most people had a computer like this rather than a graphical computer. You had a terminal with just text on it. So even though the first web browser that was invented was actually graphical, most browsers at the time were text-based. And so all of your HTML would be rendered just as text. So CSS wasn't invented yet, and there was just HTML, and your markup dictated how your web page looked in the terminal. So if you had no CSS, I'd say this is mostly what your website would look like. But most of us would think about this when we think of an unstyled web page. If you only have HTML, you haven't added any CSS to it, this is generally what it looks like. But this has CSS. This is styled by something known as the user agent. So the user agent is the style sheet, or the user agent styles is a style sheet built into the browser that's just a CSS file that says how do things look before you've declared any of your own CSS. So I've got a user agent style sheet right here. That's actually too big. Oop. So this is the Chrome user agent styles. So it's just a CSS file, and in Chromium browsers like Chrome, Brave, Edge, all of the new ones being invented, they all use this. So you can go down here and you can see it's just like regular CSS, but this is on every single person's website, and this is applied before your styles. So if you have no CSS, this is what your HTML would look like. And we can go to the body here, and you can see you have a default margin of 8 pixels around the body. So I'm sure anyone developing websites would know there's always that bit of margin around the body, the white space to separate your text. So if you have no styles, it doesn't go right to the edge. Who's noticed that when they're building websites? Not too many people. Okay. It's also display block. So you know how some elements are display block, some are display inline. That's actually defined in the user agent styles. So this is where it all happens before you style anything. And we can also go to, say, the H1, and you can see here the font size by default is 2M, and the margin uses this weird __ QEM unit. We'll get to that. So there's all these styles, and you can keep going on forever. There's tons here, and most of it is just form input stuff. So __ QEM, I never really heard of this until I delved into the user agent style sheet. It's a WebKit unit. It's because Chrome is based on the WebKit browser engine. So Chrome uses Blink, and Blink is based on WebKit. Basically, browsers nowadays are just forks upon forks upon forks of ancient browsers. And it's essentially 16 pixels. So most of these styles, it all ends up being defined as pixels. How big is a pixel? So a device pixel actually, fun fact, pixel stands for picture element. So a pixel is the smallest element of a screen that displays its own sort of color or value. So you can see here on the left, we've got LCD displays or LED displays. This is what most people use. This is what you're looking at right now, where you have RGB lights, and a huge array of them forms an image, different varying levels of brightness. It tricks your human eye into thinking that it's a certain color by just displaying 3 colors. And on the right here, you can see a new technology, e-ink. Does anyone have a Kindle or like an e-reader? Completely different display technology. You'll notice that if you power it off, the screen still displays an image, and that's based on ink just flowing inside a chamber, and it can switch colors based on the fluid inside there, which is really interesting. So you can see pixels vary depending on the technology. So how would we define the different sizes between these pixels in CSS? And then you've also got pixel density. So, back in the day with early Android phones, you had these tiny little screens where you could easily see the pixels. It was very low resolution. You could see lots of pixelation. But nowadays we have retina displays, and we have these massive, like modern mobile devices have a higher resolution than most desktop computers on a tiny little phone. So you have a really high pixel density, lots of pixels in a tiny little container. So if we had a CSS border of 1 pixel on both devices, they would look very different if it was a device pixel. You'd see it really easily on the old device, but on the new device, you'd barely even be able to see it, because the goal nowadays is to have pixels that you can't even see. This is how Mozilla defines a pixel in CSS. So it all seems kind of wishy-washy. We don't actually know what a pixel is. Like, what size is a pixel here right now? We have no idea. It's completely up to the screen. And on top of that, if you zoom in on a web page, it directly impacts the size of a pixel. So if you zoom into 200%, a pixel is now double the size. So what size is a pixel? We don't know. It's entirely up to the device what size a pixel is. As web developers, we have no idea what size a pixel is. We know a vague definition where MDN had that vague definition for us, where it's enough to see, but it's not too much that you can see pixelation. So it's very vague, but this is the most precise measurement that we have on the web. So it's a lot of guesswork. But to quote John Alsop, control is a limitation of the printed page. So on the web, this is back in an article from when CSS was first invented. John sort of had this quote where we were trying to come from the printing press, where you could control exactly how big a page is. An A4 page is A4 size. You can't zoom in on a page that you're holding up, piece of paper. You need a magnifying glass, or you need to pull it closer to you. Whereas on the web, you can zoom in, you can increase text size. There's all these accessibility options. So control is a limitation of the printed page. And on the web, we don't have that control, but that's a good thing. So not knowing how big a pixel is a good thing, because it means the user can zoom in. It means users with visual impairments can easily see your website. And it means that any device will have a web that looks good to that device. So we don't want to know how big a pixel is. But let's base everything off a pixel so that we have a clean slate to know how big things are on the web. The first thing we base off the pixel are print units. So I know I just talked about the web being better than print, but some people actually use CSS for printing things. And we have a bunch of units for that. I've never used any of these. I don't think you should memorize them. But if you want to print something with web technology, go and look into them. Now you know they exist. So you've got, centimeter, millimeter, and all the American freedom units, and this weird Q. And all these absolute units are based solely on the pixel. And we call them absolute units because this is as absolute as we get in the web. So all of these are sort of based on each other. They're all the same level. But having absolute units means we have relative units. The first of which are typography units. So a user can zoom in on your page, and that increases the size of a pixel. But they can also go into the settings and change the font size, meaning they don't want everything zoomed in, they just want the text bigger. And for that, we have all these units. So the main one I use is M, which bases the font on either the parent if you're declaring a font property on an element, or if you're, say, working out the padding around a button and you use M, it bases it on the font size of that button. So essentially, you can scale anything you want based on the typography in action. So if you increase the font size on a button, the padding will scale with the font size, which is really useful. CH I use a lot for determining how wide a certain paragraph is, because generally on the web, or generally anywhere, you don't want a paragraph being too long. It starts to look nasty. So you want it nice and short, and I like to base it off the character. So that's the width of the 0 character is 1 CH unit in CSS. Those are two that I mainly use. I've never really used cap or LH, IC, EX, but they're all different variations on the typography. So they're based on the size of the font that you've loaded in. And they can be useful in certain scenarios. It's good to know that they exist, but you don't have to go and memorize it. We also have some root typography units. So these are the same as the general counterparts, but instead of being based on the current element or on the parent, they're based on the main font size of the entire page. So that's, again, based on either the user settings, which they might zoom in the font size, or it's just based on the default 16 pixels per rem, or M. But what if you want to size something based on the viewport? You don't care about the size of a pixel, you don't care about what font settings the user has, you just want your hero to fit on the viewport that you're starting off with. You want the entire thing to fit perfectly. And you want it to work on any device. So you can't just hard code in how high the hero section is. It has to work on all of these. I forgot to change the title there, whoops. So these are viewport units. So who's heard of these? Anyone used viewport units? Not many people. Who's a web developer here? Okay, that makes more sense. Hopefully all you Android and iOS and all the cloud and backend, hopefully you're learning a lot here. So viewport units, we've got VH, which is the height of the screen. We've got VW, which is the width. So they sort of, one unit is 1% of that dimension. So 100 VH is the whole height of the viewport, and 100 VW is the whole width. And then we've got VB and VI. These are logical properties. So we've kind of we're future-proofing the web where, I think one style of like Japanese language has the block direction the other way and the inline the other way. It's like rotated 90 degrees. It's really weird. But in standard English, your block direction is just down, down and up. So you've like block and inline elements, you have block, 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 and then inline is just left to right. So VB and VI would be the same as VH and VW respectively. But then you've also got Vmin and Vmax, which I find really useful. They basically just pick which one's smaller or which one's larger of the two. So if you use Vmin and VW is the smaller one, it'll pick that, else VH. So you might want to use that, say, if you want to scale the font with the viewport, you want a larger font on a larger viewport. I usually use the min, so that on a phone with a small width, the font isn't massive, and on a desktop with large both dimensions, but the height is smaller, it scales with that. It's really useful. But I mentioned viewport on a phone, so you often have all these UI elements on a phone. So you may have noticed that when you're scrolling a web page on your phone, you don't have much screen real estate. The phone's quite small. So browsers have gotten a bit sneaky with that, a bit inventive. They've said, hey, what about when you start scrolling, we'll just hide all of the UI elements on the browser. Let's shrink the URL bar. Let's get rid of the home button and all that. So when you start scrolling, the viewport changes size. Well, what if we want to style something based on that fixed viewport and now it's changing on us? How do we, as designers of the web, figure out how to size things based on these changing viewport sizes? Well, let's create some new units. So let's say we have a large viewport, which is, all the UI components of the browser are hidden away, and you're just seeing all the content at its maximum size. And let's have a small viewport where, the URL bar is taking up all its space, the home button and everything are there. This is the smallest the viewport gets. Let's have those two viewports. And then let's have a dynamic viewport that changes based on whether you're in a small or a large viewport, and when the user starts scrolling, that value will change live. So now we've got all these units. Wonderful. Okay, so we have the large, small, and dynamic viewport equivalents of all the old units, and we'll keep the old ones for backwards compatibility. And in your declarations, you can easily just say, if you want the hero section to be the small viewport, you can write one declaration, height 100 VH, and then directly below it, you can write height 100 SVH. And if the browser knows what these new units are, it'll make your site look better. If it doesn't, it will still work. So let's also use the old units as resilient CSS. This is a site that a friend made where you can view the difference between all these new units on a hero section of this website. So you can see here I've copy-pasted two versions where one of them, your important section at the bottom, is fully visible, and one of them, it's chopped off. So you can see the difference between these units that you're using, which one you might want for that use case, which one's going to break that section on you. Yep. But we build components on the web. We're using frameworks, and we've got React, and we might not know the size of the viewport, but we know the size of our component. So what do we do then? Well, let's add on some container query units. So we can set an element to be a container that essentially creates its own little mini viewport, and let's use all the same viewport variations for the container that we're in. And that will size it based on that container being essentially the viewport of that component. We've also got the percent unit. So the percent unit is strongly based on where you're using it. So if you're using it for the width, a percent is based on the width of the parent element and all sorts of other complicated things we don't have time for. But if you're using it for font size, it's essentially the same as M. So width is heavily dependent on where you use it. MDN describes it not technically as a length unit, but as just a regular unit based upon where you're using it. So it's a very good, well-rounded unit because there's so many different properties using it, and they all have different variations on what the percentage is of. We've also got the FR unit, mainly in grid. I heard tonight someone uses it in Flexbox. I haven't delved into that. It might work in Flexbox. Let's find out. But the FR is essentially one fraction of the remaining space. So with grid and flex, you've got a container where you can specify a set width or height of something, and then you have remaining space left over that you want to fill up. So with grid, you might have 3 columns. One of them, you can set 30% of the width. That's fixed. But then you have all this leftover space, and FR essentially gives you the fraction of that remaining space. So here we can see 1 FR and 3 FR. So we divide that spare space into 4 FR and distribute it among the 1 and 3. Really useful unit for grid especially. But with all these units, we've now talked about 51 units in CSS. Which one do we use? My friend Kevin, who has a YouTube channel on CSS, he's made this map where you can easily look up what you need the unit for, what are you sizing, and he tells you how to get to the unit that you should be using for that use case. Really useful site. So this is all the units in CSS now. Don't worry, you don't have to know all of them, just enough exposure to them that when you need something, you know to go and look there. Oh, I heard of this viewport unit for that use case. Let me go and look into that more. Don't forget the keywords. Keep using the keywords. If you don't need a precise value with a unit, you can always use like a min width or a max width, which looks at the content itself. How wide do you want to be? Oh, I want to be this wide. Automatic. And don't forget functions where you can work out the minimum of 2 values or the maximum, or calculate a custom size. SAS used to be where you could merge 2 fixed values pre-processed, but now you can do it live in the browser. You can add 2 pixels and 5 rem live. Scan that QR code if you have any questions. There should also be my LinkedIn and a bunch of links to some further reading if you're interested. And let's connect on LinkedIn. I'm also looking for work in front end or full stack if anyone knows anything.
What is the most common accessibility mistake you've observed when it comes to sizing things in CSS? And if you don't mind repeating the question, would you want me to just read it out? For the online people, what is the most common accessibility mistake you've observed when it comes to sizing things in CSS?
Accessibility mistake. I don't spend enough time on accessibility. It's always a weakness. I would say most people ignore the typography settings in the browser. So most people, actually it's kind of both ways. So you start out using pixels. Let's use a pixel for everything. This is an awesome unit. I want my font size to be 20 pixels. Screw the user's setting, it's 20 pixels. If they increase their font size, doesn't work. And then you move on to rems. Rems are awesome. Let me use rem for everything. Let me size my images with rem. Let me size my spacing between sections with rem. Let me just do everything in rem. Screw pixels. But now when the user increases their font setting, everything else increases, not just the font. So I think looking specifically into what are these units actually here for? How can we respect the browsing experience that the user wants? And what units should we use for that?
Do you have any suggestions on good AI tools to use for quickly writing CSS?
So the issue with that is, like we've seen tonight, CSS is evolving very rapidly. We're getting a lot of new units, a lot of new features, and they're just constantly adding stuff at the CSS working group. So AI is trained on a data set of lots of obsolete CSS. So if you ask it how to solve a problem, it's not going to know about all these new features, and it's going to produce ancient CSS. So I believe in the future, hopefully, all this new code will be fed into AI, and it will actually be able to help. But at the moment, it just gives you terrible old code.
If you could use only one CSS unit ever again, which would you choose? Really awesome questions.
I'd choose the pixel, because like we said, it's the baseline for everything. So you'd miss out on the typography settings, you'd miss out on the viewport, but most importantly, you would get the precise nature of what looks good on each device, which is pixel based. So the pixel is calculated based on, like I mentioned, DPI and everything, and zoom. So I think pixel gives you the most bang for buck in terms of units, and you would miss out, you'd say the typography and the viewport are a progressive enhancement that you're missing out on if you were to just choose the pixel.
Makes sense. Sorry? One more? I'm going to pick my own. Regarding the sizes, the pixels, the units that you mentioned for the small devices and large devices, or with or without the expanded UI elements.
Yep.
Was that LVW and SVW? Was that those?
Yes.
Anyway, how can you define something differently based on the state that the view is in at the time. Does that mean that if it sees the CSS for LVW, then it will size it if that's the state it's in at that time?
No. So if you say, I want my hero section to be 100 LV, let's say LVH. If I want my hero section to be 100 LVH high, that's saying even if the screen is cluttered with all the browser UI components, I want it to be as high as if they weren't there. So it's not looking at the live state of those UI components. If you went with small and the UI components were gone, you would have extra space and it wouldn't update with those components. That's what the dynamic viewport is for. That dynamically changes based on those UI components. That's the only viewport unit that's changing based on that.